Hey there everyone, how's everyone doing? It's Pranesh Sharma here, and today I am back with a brand new astronomy software, which is Stellarium. So it's an amazing software, and we use it for locating objects in the night sky. And the software gives the exact location of the objects, like the sun, which is in the southwest direction. Sorry, in the west direction. And if I go outside and look at the west direction, then the sun would be at the exact location. Alright, and to show its features, I'll just quickly time warp tonight, I say dusk. So it's 21:34, which is 9:34. Okay, and as you can see, this will be the night sky at the time. So these are some meteor showers. We'll just come to them real quick. So like if I click on a star, like this is Vega. I press the space bar for focusing towards it, and then you can zoom it. So you can see lots of stars are also emerging slowly. So this I have focused on Vega, and this gives the name and the scientific, or I think the astronomical name. And then this gives the type of the star, which is a pulsating variable star, and it's also a double star, which means that two stars are revolving each other. It's a binary star, and magnitude is zero point 0. So magnitude means that how bright it is looking in the night sky. Sorry about that, vehicles are going outside. Okay, so it's zero point 0. It means that it is matching, it's a little bit bright than the other stars, like this one is zero point 0 and this one is 2.2. So this one is much more brighter than this Altanin. Okay, and um, now these are some tools bars. We'll come to them real quick. Okay, now this is like Arcutus. Now, so this is absolute magnitude, then color index, declination, then these are some geographical locations, the geographical things, and this is the rise, which is 39, and transit means it will be there for this much time. Then set, then spectral type, parallel, angle, position. Alright, these are if you are really good in astronomy. I don't know, I never use them. Okay, and that's the Milky Way, as you can see there. Now these constellation lines, these are some for the constellation tools. Like if I click on constellation lines, so these activates the constellations. Like this is Ursa Minor, the Ursa Major, and now the constellation label. So it gives the name: Ursa Minor, Ursa label, Leo Minor, Canis, Venti, Tinci, something like that. All right, and the constellation art, so it gives the images how our brain thinks of them, or I don't know, like how they're supposed to be. Like this supposed to be a bear, a lion, then the dragon, Hercules, like that. Okay, and then this is the equatorial grid. So it tells where the north star, it's Polaris, like it's here. Okay, it's the Polaris, which we call the North Pole Star, I suppose. Yeah, the Pole Star is the Pole Star. Okay, and then the azimuth grid, which tells the exact um, the point which is perpendicular to us. Then these are the ground and atmosphere and direction settings. Like if I remove the ground, so now you can see everywhere all the universe. Okay, and that's the moon. Then these cardinal points are for the directions. It's like northeast, southeast, alright, and that's for the atmosphere. Now you can see the difference between that atmosphere and no atmosphere. Atmosphere absorbs some light from coming from space of stars, and as soon as I remove the atmosphere, you see the difference. You see, like this part, it's like nearly blacked out, and boom, so much stars. So there are a lot of stars out here, as you can see here, and the beautiful nebula of Milky Way is going like this. Alright, it's going like this. Now we'll just activate them all. Then if you have these objects are visible by naked eye, but if you have a good telescope, then you can use deep sky object filter, I suppose. So this tells you about the deep sky objects. Like this one is Elephant Trunks Nebula, so it's a nebula. Alright, as a cluster associated with nebulosity. So this is Elephant's Trunk Nebula, and that's another thing. Um, a star cluster, I suppose. Okay, and I'll real quick tell you about the how galaxies look. So we'll just time warp a little bit. So to go back or forward in time, you use this. So like this is going back in time. This is for real time. This is for current time, for location, and this is going forward. So there comes Andromeda Galaxy, which is the nearest galaxy to us. It's about 22 million light years. So I'm focusing towards it, and we use this oval shape for denoting galaxies in Stellarium, and that's the Andromeda Galaxy. I think you're familiar with it. Okay, and just like that, we can use planetary markers, and right now I don't. That's Jupiter. Okay, so Jupiter is right now high in June, and we can zoom in. So the four moons of Jupiter: Ganymede, Io, Europa, and Callisto, and that's Jupiter. There are some other moons also, like you see it's moving when you click when you focus it, then it goes with the star or planet. Okay, and this one is for Centron. These are some focus things. Alright, that's full screen. This is night mode, like if a red eye. Then these are for exoplanets. You can also see exoplanets, like this one is Muskia. It's a planetary system, and it just shows like a star. Okay, if you have a really good telescope, then you can watch it. Oh my God! Whoa! What's that? Yeah, I saw it. These are Kepler systems. Oh my God! You look at that. That's the universe. So many star systems. Kepler 1000, 1558, 13, 1344, 178. These are also giving the names of the planets, like it has three exoplanets B, C, and D, so we'll name it as Kepler 178b, 178c, 178d. I think these are the period of revolution. 9.58, 920, and 96 are, and these are the mass. It's not their radius. And radius of Jupiter, so this is 0.3 Jupiters. This is 0.3 and 0.4. Semi-major axis, sensitivity, inclination, angle distance. Discovered year, so these were discovered in 2014. And detection method: primary transit, primary transit, primary transit. I don't know what that means. All right. Yeah, but look, so many exoplanets are there, and we might find someday life on these planets. Why is this one red? Do this mean that they support life or what? And we can't even see anything now. Okay, metallicity, what's that? Okay, we'll just leave these exoplanets here, and these are for meteor showers. So these tell about meteor showers. So do you know what are meteor showers? Meteor showers, they are like some debris of comets. They're crashing into the Earth's atmosphere, and they cause like shooting stars. Some people do wishes with them. So this one is June Botid's, and it tells every information about it. So you can even look at it, and I have many time used Stellarium for locating these. Like it's in northwest. This app is also available for phone use, so you can also use phone, and that by turning the phone to the direction, it tells you exact location. So it says that activity is 22 June to 2 July, and maximum is on 27th June. So I'll be checking it out. This tell how many stars, how many meteor showers can be appear, and oh my god, it's about 0 to 100 so per hour, I think so, and that's really a lot of. And velocity would be around 16 kilometers per second. That's Saturn. If I look at it, I'll just post it. So these are some moons like Epitus, Rhea, Dione, Thetis, Mimas, Janus, Enceladus, Titan, Hyperion, something like that. Alright. And then that's the moon, looking beautiful. How does it look without the atmosphere? You see, the atmosphere is little bit squeezing the light from moon, and that's why it looks a little bit squeezed. Alright, and oh, we even found Neptune. That's great. Let's look at Neptune. You can look at anything in space with this. Oh wow, let's remove the atmosphere and the ground. So these are some rings of Neptune. Oh, you see, it's really fast. Proteus, Lycera, blah 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 blah. Triton. Okay, so and now that's for searching some meteor showers. Search dialog box, so it tells you about the meteor showers. Like I can check in July, from 1st July to December, or yeah, okay. Search. So these are all the meteor showers which will be occurring. Like office should something like that. I'm really good, and it's down severe. Okay, atmosphere. Okay, it will be some time later. Oh, sorry about that. I just time up a little bit faster. Okay, that's good. And these are for satellite, and I don't know why this feature is not working. Otherwise, it would display all the satellites right now. Geo, all the geosynchronous and mobile satellites, and these are the location window. So you can search your location and okay, and then date and time window. So you can set your date and time. Okay, and then sky viewing options. So there are a lot of sky viewing options, like for the projection the view. So this one is stereographic. Then you can use fisheye. It's like a fisheye, and this is just dump. I don't like it at all. And there are even others like Slindrel. Oh my god, it's like a depression here. The best one is stereographic only. Sorry, this, yeah, stereographic. Then for solar system objects, like show planet markers, use scale moon, show planet orbits, show planet. Oh, so these are the orbits of planet. You can see there. This is the orbit of Jupiter. What's this orbit for? Pallas. Oh, we found an asteroid. It's Pallas. Whoa. Oh my god, I just focused also. That's awesome. So if you have a good telescope, then you can just focus on any of these. Then the Jupiter. This is the orbit of Jupiter. Saturn. So they have a little bit like same orbit. And let's look at the orbit of Moon. And the moon is, I think, 4 times big. It's looking a little big. I don't know what does that mean. Okay, and we'll just real quick close setting. Then display objects catalog. So I never use this, but we can use this. Then these are markings, landscape. So you can change a landscape, like mine is grains, and you can add like you can even look like what would it look like from moon. Let me just make it daytime. So these are some images from Apollo, and this would look like the moon from the moon. And alright, you can see some footsteps. There's one astronaut, I don't know who is. Buzz Aldrin. Buzz? Edwin Aldrin? Alright, and then like from Neptune. So Neptune is just a gas giant, so everywhere is gas. If you remove the atmosphere. Oh, wow. So actually you can't land on Neptune, and how will it look like from night? So it's okay, but it's really scary. And from ocean, yeah, it's night everywhere. It's water everywhere. Sorry. And just like that, from Saturn, Sun, trees, Uranus, Zero Horizon, Geneva, Garching. It's Green's its best. Which place is this? Oh, they have just labeled them wind power plants. Okay, well, this one is better, uh, but this one is awesome. Then star lore. These are for the star things, like how stars are named. Then surveys. So these are for deep sky surveys. So these are some things. I don't know what's there. And solar system. I think they give observations. Okay, so these are telling what are the objects of the solar system available. Like we can look at Venus, properties, data, image. Okay, so that's alright, and these I have told you, and this is for closing it. Then that's the configuration window for the some configurations if you want to. You can also download the Stellarium or buy it. Okay, and these are help windows, about, log, Stellarium, and that's the astronomical calculation windows, like for position. You can search for solar system objects and brighter than magnitude 0 0.0. So Sun and Venus are only available. We can add Mercury, Mars 3.0, like Mars. Uh, okay, and let's remove the atmosphere to look it clearly and zoom in. Oh my god, lots of traffic's out there. Okay, so these are the two moons of Mars. Alright, and that was like that. Okay, where will be astronomical calculator window, and like Fermis. And then phenomena, we can search for phenomena like between objects and planet, winds and planets. Let's make it sun and planets. Calculate. Nothing is here. Altitude versus time. So this is about mass. Then MB. Graphs. UTC. Asteroids. Palace. Then double stars. Should be Cirrus also. No. Alright. Then bright nebulae. Cave. Dark. Ghost. Bright stars. Galaxies, cluster, comets, quanbos, dark nebula, dwarf planets, and there's a lot of stuff. So I'll not show you everything. You have to check it out yourself. Okay. So yeah, and I forgot about this. So these are for telescopic views. I'm adding the atmosphere right now, and let's go to night time. Okay. So now telescope view. Please select on object, like if you want to look at Jupiter. So I'll click on this. Now these are the information about the telescope. This is ocular 0, and this is 40 focal length. Then telescope 0, its magnification is 79.8x, and exit pupil is 4.46 mm, and like lens. So we'll increase this to 12.5x, 79x, and we'll use a Barlow lens. So it's 159x, 239x. You can see Jupiter now. You can even change the telescope, like this one is ocular one, which is 368x magnification, then 76x, then 122x, 3244, 38. Then another one, ocular 2, 205x, 32x, 205, 308. So this is 308x magnification. And then next one for ocular 3, 299x, then 622, 99, 199, 29, 4x. You can have good views with some telescopes. Then Celestron 170 Sky Master, right, and then this one is awesome, the Celestron Micro Guide. It has the highest magnification, at least for this, 765.6x. So you can see a lot of moons of Jupiter, like Amasalia, and I can't say this one, Adrastea, Io, Thebe. Then this is one for adding some red pointer. This is for sensor, I suppose, a sensor 00, like this one. Okay, then you can move this sensor like this. It's just for fun. And that's one, I don't know. And this is for some configuration of the oculars. Okay, so that was this. I think we covered everything in the Stellarium nearly, and you can use it for your astronomy purposes. Okay, and that's all for today. Thanks for watching, and for more videos, don't forget to like and subscribe.